little update, I'm not a solutions architect anymore, I'm now a forward deployed engineer. Because this is something you have to put on your resume if you want to be cool and hireable. So I'm already updated it. Not going to talk about the FDE role. I want to talk a little bit about some infrastructure part. So how we're going to implement with the customer GPU support. And that was a really interesting practice. And just let me share a little bit. So we're not going to use coding agents or something around skills and so on. So if you're like, hey, I want to learn about skills, that's the wrong session. So we talk about how we deliver actual AI to the people. Everything started as usual. I'm a solutions architect. I work with customers with a customer call. So me, that should be me, you know, like, oh, what's going on? Okay. And actually, it was a little bit more like this because it's reality, you know, you're like, what's going on here? So customer in Slack is like, I mean, they're not telling, not everybody is saying bro to me, but some of them actually do this. So it's like, hey, bro, how are you? I have an idea. And so we need to implement something. We need to schedule a meeting. And as usual with customers, it's like, can we do it now? It's not like, hey, let's do, because people have an idea and they want to solve this, okay? And yeah, that's me reading this saying, oh, okay, that means I have to do something for my work. I cannot point my open claw to it. But yeah, okay, so a customer called, European customer. I'm based in Germany. You can hear this probably. This thing will not work very perfect because I have a heavy accent. And these machines have always problems to pick it up.
But it's perfect.
Look
at that.
Is it perfect currently? Okay, fine. So I should speak quicker. So in the automotive area in Europe, you can guess there are not that much where I'm from, has an idea to extend the internal AI for support for the whole AI stuff. You know, hey, the platform needs to support now also AI. And here comes the thing what enterprises love very much. They love to see what others are doing. So they browse, they sit together and then they watch, they say, hey, do you know Volkswagen or Mercedes-Benz? They have now a cluster going on. And the guy's like, wow, we need to do this also. And then there's another study, you know, like, yeah, here the Volkswagen group has also something created. And last but not least, Continental, hey, we have also something created around this area. And then you can imagine that the other CEOs or CTOs are like, wow, we have to also do something around this. And then, yeah, that's the point where we come into the game. Okay, I have to say something. We did this a time ago, so some of the things you will see are maybe outdated. We also go and discover some new technologies. We also saw the latest release around Groove and Kai, for example, what NVIDIA donated. So some of the points are maybe like, oh, that's not up to date. Hey, AI space is going hyper quick. Okay, so in the world, we had, in the classical world, where the people had to work, the engineers had two knobs, let's say like this, two knobs to work on it, to say, okay, how we can deliver GPU-supported workloads. So you have the classical device plugin in Kubernetes built in. You will see where the story goes, where you just set up here a specific number and say, okay, I want that the pod gets one GPU or nothing, you know, there's this specific thing. And then you can say, okay, I'm going to run now here an 80 gigabyte on an 80 gigabyte A100 serving a 12 gigabyte model. And here comes the point. This one is only using 30% of the capacity. So you can see where the story goes in this classical world with the classical device plugin. And then also the system like, hey, let's be smart and let's use one of the things to make it more effective when we have the GPUs in place. Yeah, let's use time slicing. I mean, yeah, again, we talk about back times. So, and here comes also the issues with time slicing. You know, you set up your time slicing with your operator, and then you come to a situation that you have no memory of fault isolation, no guaranteed compute share, and then you get some metrics go a little bit lost in the system. So it's not really, really good, but that was the things you had in the time when started. I mean, yeah, there is another one. Sorry, I have a chewing gum in the mouth and I don't find out. Sorry. Is this recorded? Okay. So
I hope so.
Another thing is, what you could do now is throw money on it. That's the best thing, you know. Our government does this in Germany. Throw money on the problem. But here comes another point. GPUs are expensive, you know what I mean? This is now really expensive. It's not like something the guy's like, yeah, just buy a graphic card because maybe he bought for his son or whatever a graphic card. yeah, it's 2026. These things are expensive as hell. GPU, RAM, and all this stuff. Everybody is buying, and we're not talking even about electricity and all this stuff. Okay, but here comes the point, and I have to quick up because I have the tendency to talk too much. Then things started to change. So one of the changes is now there was a new way how we could schedule now, because we could now schedule on a system using attributes, using GPU attributes, not going in the classical one with numbers and all the stuff. We can say, hey, and this is the functionality I want to talk, is the DRA, you know, the dynamic resource allocation, which went GA with the Kubernetes version. I hope there's no Kubernetes ambassador here and knows it better. So it's 1.34, which got released at GA. So you could activate this depending on what cloud provider. If you self-run, you could activate this feature flag already. But if you're like, hey, I want to have it safe, it's GA now in this one. And now we have a ability to look inside now in a GPU and not talk anymore about numbers. We could now literally go about attributes and set some attributes and say, hey, a product name, an architecture, you know, Hopper, Ampere, Adder, and all the card things. And then also going here, we're coming closer to the MIG one, going here also with slices and say, okay, this there's a MIG profile on this graphic card, and there's a specific slice I can use, and so on and so on. And here comes the next point, because I also don't want to speak too much about DRA, because, hey, we live in an agentic world. You can look these details much more up. But one thing is, it should be very familiar with things we learned in the caveman time last year when we created storage classes and all the stuff. So the system of DRA is heavily borrowed here from the way we already worked with Kubernetes around the persistent volume claims and so on. I mean, they even use the same names, so what should I say? Okay, so yeah, if you ever have written a PVC in the caveman style, then you already know about this, and it should be no problem for you or your agent to do the same. So what's on the cluster side? We're going to define here a device class where we use this, I never get the drill out of cell, where you can use cell and the expressions to then go for the attributes and pinpoint them down and say, hey, this specific resource class, I give it a name and it's going to pinpoint one specific setting. And then you have also the resource slices where you put the stuff together. This is on the cluster side. And on the workload side, which is more interesting us as platform engineers, that we're also going to not make the back end, but also how people are going to use this for our golden path, to say whatever I'm doing on a pod, for example, I can use now the resource claim, point on this one and say, hey, run this workload now on this one. How I defined this with the attributes. And the same goes if I'm going on the template side. I can say, okay, use the resource claim template, which I defined here, and then you can put it in. Okay, so that's the thing. And now comes the next point. How are we going to get the most out of the GPU? Because, yeah, GPUs are expensive. We don't want to have idle stuff lying around. We want to get the max out. And here are 3 systems which established. So we have the MPS one, the multi-instance GPU. You see, you run here with a CUDA context and different processes. We have the time slicing I mentioned before, and now we have the MIG, where we actually want to go in from NVIDIA, and then we have GPU instances on your GPU which are completely isolated, and I start to spoil my next slide. So yeah, that's what I said here with the CUDA context and no fault isolation, so that's blah, don't use this anymore. And then we have the time slicing, equally bad, so don't use this neither. I mean, it's a little bit better than the MPS one, but yeah, has still some problems here, especially we know from the Kubernetes world, nosy neighbors. I have a neighbor which is a little bit noisy. He plays guitar. Every evening my wife goes mental when he plays this. So nobody wants nosy neighbors, and this is the thing also here with the time slice. And then the better one is here from what NVIDIA presented here, that we have the real hardware partitioning, dedicated memory, dedicated cache, fault isolation between the slices, and depending on the card, you can up to 7 slices per card, which is really, really awesome. A little gotcha, it's only for specific cards. So you need to be in this area to play with this. So have a look on this one. But most of the cards in this category, which are also a little bit older, they support this. Okay, So where we are, yeah, I keep on spoiling my stuff. So we started to build this. And this is a carved out example, you know, to really run it on EKS, so you can run the demo code and say, how does it look like if I want to run this also? So we have our Kubernetes cluster here, in this case on AWS, and then you have your different pools. You can go crazy with Carpenter, and then you have your NVIDIA driver, your Prometheus, Grafana, Argo CD, everything you need to run up your system. And then you have your resource claims, and then you can carve out this MIG slices here, depending on what you want to do. This is what you build. You say, hey, I create one slice only for batch jobs. I create one for inference, for large, for example. It's really up to you. Okay, and it's all done in Pulumi, so that's also the positive part. And as you can see from my shirt, if you want to have a shirt like this, I turn around, hit us up, and then we can connect you and get you also a shirt. I didn't have space in my luggage to bring you enough shirts. But yeah, okay, so let's do also some little bit, how does it look like? So one GPU, 3 pods, I hope that's... Okay, so good that I prepared a lot of alternatives for this one, and also is to use AI for this stuff. So I can say, hey, can you run the demo and show the output as table? I also prepared a little bit a pre-run thing. So let's Claude cook and create here our output. Still thinking, it's like me. And now it's going to burn the tokens. And hopefully it comes up with what we last year would do with kubectl commands and so on to show you like, hey, this is working fine. Because the most important part is here to show that these 3 workloads we created now are running on the same pod. So that's the most important thing to show while this is running. Let me also show you here the Grafana one. So we can see when I deployed the demo, we see the spike. That workload is now scheduled on this specific slice, and that's the thing to show. You see, it's not that sexy like having some agents running, 10 agents, 20 agents, and doing slop. This is real engineer stuff. So what's going on? Okay, it's done, and we see here now, we see the class, the node is ready, the GPU node is ready. I had to buy a reserve at AWS because this thing is not available. I shelled out 340, Paul, don't say this to my manager, 330 to reserve the node just for the demo to show you folks. So it's attached. We see they are all running, the inferences are running, and we see that they are all on the slice as we expected. And what's going on? So here allocated devices are allocated and everything is running up to the point. So let's head back again to my backup. You could also run this with kubectl commands and you would see the same here. That's what we want to show. Perfectly fine. Okay, that's the video which I cannot stop. So let's go back because you see the elements are blocking this. Okay, so but that's, again, we have some questions around this again. So people are like, hey, Engin, that's nice, you know, that looks like it could work, but does it really go proof in a large company? So yeah, day 1, 3 pods land on the 3 slices, 1 engineer, 3 workloads. Yeah, that's fine. But here comes the point now. Rarely companies are, you know, just 1 person or 2 persons, especially in the segment we want to work in, where people really have pain on a larger scale to solve. So think about now 50 engineers, 1 slices, and then we have training jobs, inference pods. They compete all for the same slices. So whose workload run first? And here comes the thing I mentioned with the Disney slide to say, okay, this is where we have to put work on it now. So we have the Kai scheduler and we have the NVIDIA Groove, which purpose different points, which also work very well with the MIG operator of NVIDIA. And this is something to say, okay, how does the future goes and how we can use this kind of project. They were donated last year from, I think during Amsterdam, or was it something around this, to the NVIDIA CNCF. So this is something we have to work, and I can't give you an answer on this one. I have to be honest here. Okay, but now what's your blueprint for your Monday? So either you're already there or you are going to be about this. So let's pull out some some statistics from Vulture. They did a survey, and they say, okay, 75% of platform teams are already hosting or preparing AI workloads. 30% have already extended Kubernetes to support GPU and AI, so that's good. We are in good company here. And 39% say platform engineering owns AI in their org. And here comes the point. I talked with some people in another conference, and they're like, Engin, they started a shadow AI inside our company because they're not waiting for us and so on. And now he had this project, he has to collect the people back again. So he taught me, I did a talk about LLM, about the AI gateway, and that was like, okay, with LLM, with the light LLM AI gateway, you have now the chance to have bedrock and frontier models and have them all exposed through your way. You can attach some guardrails and stuff, and that was interesting because, yeah, guess what? People not waiting for you. That was in the past, so, and it's in the future. It's still the same. People just go ahead, and we as platform engineers, we need to run this. You probably are too, or your CFO is about to ask you why we are not in this thing, why we did not start with this. Okay, so, but again, we are 2026, and we should not pretend that things are as they are before. We need also new touch points. If you had the chance to visit Whitney's talk just this morning, she also talked about new ways to interact now with your IDP, and I have the same because, and I was very happy to see this confirmation from another colleague, like, hey, people ask now for new ways to interact with our IDP. So in my case, yeah, you could go MCP. I know MCPs are not the thing anymore, but you could still go with MCP and create your tools. And which is more interesting now, where Pulumi is also investing a lot of time with the engineering people, talk to them, is to get your CLI up and ready for AI usage. So evaluate your CLI. I'm a vendor side, okay, yeah, our CLI. But maybe you want to create for your IDP now also a CLI because it goes very well with this additional thing called skills. And then you can either make a Uber skill, or in German we say an Uber skill, which does a lot in your IDP, or you carve out some sub things, make it as a marketplace for people to internally install, and then they can use your IDP where they are currently. They are in the CLI, in the coding agent, and so on. I mean, even our CMO use Cloud Desktop, so let's figure this out. And yeah, so now the dev can go in and say, hey, I need a slice, blah, blah, blah. The skill triggers, the tool runs, and the PR appears as we want to have this very auditable. We can still use the old stuff using PRs and all the thing, but now let people use the communication thing. And very important, yeah, guardrails. Oh yeah, 5 minutes, that's good. Guardrails. So implement guardrails. We at Pulumi have, for example, our Pulumi policy as code tool in place. You can activate if you're in our Pulumi stack. If you're somewhere else, Whitney used Kyverno, for example, on her Kubernetes stack, so you're completely free to do this. But having guardrails is very cool. It protects you from stuff. I talked about light LLM. In light LLM, you can also create guardrails, and not only about profanities or whatever. I'm swear with my AI. I have to be honest, when I saw Whitney use Datadog for tracing this stuff, I'm like, wow, I need to be careful if somebody traces my stuff. Okay, yeah, that's, you know, I'm Turkish also. My parents are from Turkey, so we have a lot of swear words. So I can use German and Turkish, and it's a wild mixture of swear words. I swear you, that's, you cover everything. Okay, but sorry. Okay, so, what is the thing at the end? So yeah, devs ship faster, and now it's the most important thing, and this is like a stigma we don't want to have on us. That was back in the day, and it's even now. We are like in Monopoly, back to start. People want to accelerate, and we should not be the bottleneck. You know, I don't want to be, and I told several times, I used this phrase, I want to be part of the solution and not the problem. Hence, taking care of this, owning it quickly, and providing people a smooth experience. And it was the same like before. I mean, 2 years, 3 years ago in the old world, funny to say like this, it was still the thing we'd call DevOps, don't throw shit over the fence. I should not talk like this. Okay, so yeah, that's it. I mean, that's, as I mentioned, a very quick talk to give you an idea and how things are working. And yeah, give it a try. If you not use DRA, give it a try. If you want to use more slicing techniques, then go directly here and investigate also some of the new projects. if you don't have any questions, you don't have because I skipped, I would say thanks. And here are some credentials of me. So this is the demos. So if you really want to run it, I tried it. Don't do this caveman style. Just tell Claude to look up this thing and run it for you. Or use Claude to, hey, you use Terraform, say, hey, this Engin guy, he made it in Pulumi, I want to use Terraform, go translate it. So it's completely free. And this is my LinkedIn. I think it's my LinkedIn, so where I'm more serious, you know. LinkedIn is where my dad comes and look up and says, oh, my son is good. So, okay, and yeah, thank you.